Yes, that's great. So time to get started again. And I was supposed to do some introduction to lab exercises and also the project slightly. But we will have a later on in the schedule, we have a project kickoff where we discuss more about the project. So today it's more focused on the lab exercises and the assignments. And yes, so in the course PM, you can read that you should carry out a simulator lab exercise. And to clarify, it's actually, well, you can regard it as a lab exercise, but it's actually 2 kind of assignments that you pick out of 4. So we should be more clearer here, maybe. But that's the case this year. And they are not so scary. It's just a matter of becoming familiar to simulator. So it's perfectly fine. But you need to do something, and you can work alone or 2-person groups. And when you have done things, you just demonstrate everything orally. You talk to me, and this is really to get a feeling for what you can do in different simulators. And then you actually should do your own study. That's the project. And that's bigger and more difficult. But now we focus on the exercises first here. And for those that didn't look in the schedule, tomorrow is actually the first slot for our lab exercises between 2 to 5 o'clock in the afternoon, I think. I will be, and we will start working with this lab. You can do it yourself at home if you like as well. And there is no rush. Some of you might be demonstrating something tomorrow, but probably not. It will take many weeks. We'll see. There is no set deadline for doing these things except the end of the course. And you should do the exercises before starting the project. That helps. That helps. So yeah. So so I will tell you a little bit more now about exercises, and especially the simulators included here. And that's the Omnet++ and the Internet framework. And also, if you like Python programming, we have a frame library called SymPy, which you could use. So yes, so you should choose 2 out of 4 lab assignments. If you like, you can do all of them. It doesn't matter. But you only need to demonstrate and talk about 2 of them. That's the minimum. And using Omnet, there are 2 tutorials. One TikTok, very basic, but quite extensive anyway. And then it's an Internet wireless tutorial as well. These 2 will not require any programming or something. It's mainly looking at the existing examples and trying to understand how you can use this Omnet simulator to do stuff. If you know how to program, especially in some languages, you can do more. For example, if you like C++, you can extend Omnet models with some maybe some kind of broadcast node here, or you can dig into SymPy and do a Python exercise instead. But these 2 require programming skills. So that's the 2 possibilities here. For the project, you're free to choose whatever. You can continue using Omnet or this SymPy framework, or something completely other stuff. That's perfectly fine. I will put up the lab instructions on Canvas soon, but it looks like, let's see here. This is more details. So it's really simulation with Omnet and SimPy. You have 4 to choose among, and you should do at least 2 of them. And in the end, just tell me and I will come, and then you demonstrate that you have understood everything or most of it. And that's the easy thing. And then you're done. Yeah. What will we do tomorrow? Well, actually, quite this simulator Omnet, it's a very, very complex thing, and it might actually take 1 hour to install only, and it's not installed in our machines in the school. And it's easy that something breaks, and since it's very complex, I know people last year and previous years, they have been forced to reinstall everything now and then, and that's not so nice. But hopefully it will work stable for us here. The thing is that you install it typically in one computer, and then it's not, you cannot find it in in another computer. So you need to be at the same computer the whole time. When you end up in a new computer, you need to reinstall. So it's a little bit tricky here. But otherwise, you only go to omnetpp.org, and you can quite easily just, let's see if I press this one. Oh, so here we have the simulator. Oh no, wrong button. Here we go. So they have a preview, but it's actually this download button. That's the nice one. And then you just pick, okay, it suggests Linux here, but Windows is more easier, I think. And this is the latest stable 5.6.2 version that's recommended. It's actually over a year old, but they are developing this new, the preview version now. I haven't tested the preview version, so I'm, well, if you're courageous, you can maybe do it. Otherwise, it's easy. Just download, start unpacking this zip file. It's not an installer because the install is quite complex. It's a Linux program. So inside this zip file, you find everything. You find a Linux system, you find compilers for Linux, and the actual Omnet simulator. So, and why the reason for this 1 hour install time is that first it builds Linux and install Linux inside Windows, and then it builds all the tools for Linux. And then it starts building the Omnet stuff. So if you're in a Linux system, it's actually a much smaller download and much quicker install, because then you all typically have all the tools already installed. But
Thomas?
Yeah.
Or can I just ask, if we choose the Python variant, so to say,
Yeah.
Do we need to download Omnet?
Yes.
Or? Yes.
Yes, if you look carefully here, you need to do 2 things.
Okay, and this is okay.
And 3 of them involves Omnet.
Okay.
you cannot escape.
Okay.
And that's actually a reason, because we like for everyone to see this Omnet tool actually. So because it's a nice simulator when you manage to install and run it. So that's the kind of interesting thing. Yeah. So be careful with the installation. Read carefully everything. There is an install guide also on the web, I think, but it's included in the, when you unpack the file, you find a doc subdirectory where you can find the install guide as well. In the lab computers, it's good to actually put the whole thing in a simple place. Hopefully we have rights, all of us, so we can actually install on the root of C: drive. We'll see if that works. H drive is nice if you want your files saved, the thing you're doing. Then you can actually switch computers and reinstall and maybe still find the workspace here. But you need a lot of free space. I think you need 2 gigabytes or something. And the H drive is a bit limited. I'm not sure how much you are allowed to put there. Yes, but then you should go through the TikTok tutorial. It's here, and really look at all these parts. There are existing sample code, so you just read and try, write, think. That's what you do here. But it's it's easy to do. It's a little bit tricky, but I don't think it's that hard. Then you can also go through this wireless tutorial, and so you should only do steps 1 and 6 here, and then you should kind of follow the idea with the thing here. So it's a tutorial, but not going through all steps. That takes unnecessarily long time. And then if you want to extend Omnet, you read this part, and here it says what you should accomplish in some way. But this involves some programming in C++. And for SymPy, the last thing, there is a lot of links here. You do some, first you need a working Python environment. If you don't know Python at all, you need to practice a bit maybe first, but then you actually read about the SymPy framework and try out the examples. And the actual exercise here, the assignment, is to modify an existing model called CarWash, and you should do some modifications for that model. That's the kind of assignment here. So I will not go through this more careful like this. You will read it tomorrow, typically, when you get started in more detail. And it's better that you read and ask about things. I think it's too much detail for now. Yes, so I was planning to do a little bit introduction as well for to Omnet more, and to this SymPy thing, telling you a little bit more about it. Omnet has actually fairly good manuals you need to read, but don't be afraid of documentation. So here you have the simulation user manual. Looks like this. It's a lot of technical things, but when you start reading, it's actually, I think it's quite understandable. For the Omnet simulator, you use the internet framework for many examples, and it has its own user guide. So this is something that gets installed when you install Omnet. It asks, it typically by default installs this INET framework as well. And it's a big framework. You can use these models to simulate quite a lot of stuff on the internet. So It has a lot of stuff here. It knows basic protocols. It can handle many different routing stuff. It has switches, routers, everything. It's easy to get lost here, but the best thing is to look at the examples. So what does it look like when you start the Omnet? Well, you might get a bit confused because when everything is built and you have done all the steps, the only thing you see is in Windows, there will be no start menu icon or something. It's very non-visible. You need to open the file location of your install. I have put it on my F drive here. And then a subdirectory called Omnet, yeah, the name. And this is where I unpacked my zip file from the beginning. So here's an install. It's a README, and in the doc subdirectory, I have also an install guide and things like that. So read these guides, follow the steps to actually install and build the whole thing. When it's done, it looks like this. So it's not so fancy. And the way you interact with this is that you first must start the Cygwin Linux system. And you do it in the root catalog of this Omnet installation. And you find the min-wn command thing, which you run by just starting. And then you get a Linux shell, which is not, it's almost like the Windows shell, but it's Linux instead, and it has the correct environment variables set for starting Omnet and working with Omnet. And this is where you do all stuff if you are a command line person. But if you're not a command line person, you write cd and then bin, and inside the bin subdirectory, you will find the Omnet PP program. That's the graphical user interface. So this is the way you start it after you have installed everything. Starting the Omnet IDE, and then it's a little bit more user friendly. So yes, and Omnet is a simulator built on an environment called Eclipse. Eclipse is a kind of very popular IDE development environment some years ago. Nowadays, it's, well, I've never liked Eclipse. There are much better. And for example, it's similar to Microsoft's Visual Studio, but the Visual Studio is really much better. And most other IDEs are better. Eclipse is, well, but it works. And Omnet is built around Eclipse. So it's a development environment for C++ at the same time as it's a simulator environment. When you have started, you have all your projects here on the left side, and all projects are closed here. If you open a project, whatever, we can look at the TikTok. You double click, and the thing that happens is that you only get a small arrow here, and then you can unfold it, open it. Now, a bit tricky thing with this Eclipse environment is that you can have multiple projects open. So when you have been looking at some place here, you might want actually to right click and close project. Otherwise, whenever you start something, it will rebuild all open projects and it gets slow. You only want one project open at a time. So yes, so that's a TikTok thing. We will take a look on slightly closer here, but in the installation, to check that everything is working, they actually recommend that you well, let's step up one thing here to examples, I think, samples and Aloha. Try Aloha, they say in the installation manual. Then you see that everything works. And that's kind of nice. So we can try to run Aloha. And we get a new simulator window. But now we don't get the, let's see, oh, I need to choose a configuration here. We do the basic here, okay? So for a more advanced simulation, you can see that it can actually look quite nice. So now it's not the development environment, but now it's a simulator running. So we have different buttons here. And you can see that models can be quite graphical. These are some wireless stations, a lot of hosts talking to a server. And now it stands at the simulation time 0, really. So, and we can press run to actually start the simulation, or we can step one event at a time. But if we do run, it starts to run the simulation. And it's actually quite graphical sometimes. You can see the radio waves spreading from different nodes and things like this. And you get a very accurate picosecond time here for the model. And now we have been, the current simulation time is 400 milliseconds now. So we are soon up in half a second of events. So it's really slow. We can do fast and express, then it turns off the graphics and just calculates all the events, simulates much faster. But this is, well, stop this. So this is an example of that you can actually build quite nice simulation models and with a visualization and things like that. And this Aloha is an example. It's actually quite interesting thing. It's actually something that could be used for the project, maybe, if one are interested in wireless communication and how to avoid collisions. So we see here that another frame arrived while receiving collision. So one packet is dropped because they collide at the receiver. So that's an example of yeah, and the Aloha protocol should help out with these collisions. But yes, when we can single step one event at a time, and then we see that it's slowly stepping forward to the next point in time where the next event occurs. And events occurs typically when something gets transmitted, that's an event. And when something gets received, that's also an event. In between these send and receive times, the simulator needs actually not to do anything. But due to the visualization here, it actually spreads the radio wave here. So, but if you turn off the graphical stuff here, it just jumps to the next interesting event. And during the simulation, it always has a list of future events, things happening in the whole system. So these are messages scheduled to happen at some future point in time. And we can see here, if we click on one event, we can see that this event is supposed to happen at 2.39 seconds. So it's in the future. And so this event list is sorted according to these times. And let's see, the next event should be, maybe be at 1.23. It's 1.20 now. So here we can see that when we press step, this event will be executed typically. I'm not sure it's, yes, it's 1.23 seconds now. So this is a typical more complex simulation. You have a lot of events waiting in the system to happen sometime in the future. And it's typically each host here planning to send something at some point in time. Yes, but I think we close this a little bit, maybe stop and then finalize, conclude simulation, stop. So, and what's, how do you, and I think it might be good to show the basic TikTok example. That's a tutorial. That is one of the exercises you can choose. And it's a quite simple one. It illustrates a very simple simulation and network. And it also tells you how you can do things. So you have a lot of files here. All code is already existing. When you start doing things yourself, avoid using the existing TikTok library. Create a new project for your tutorials. You can open this TikTok to just take a look or copy code or something, but don't run and do stuff in the TikTok. It will complicate things. So make your own project and start over again from scratch. But all the TikTok stuff is already exists in the installation here for the tutorial. So if we look at the TikTok one, we have a lot of files here. We have CC and H. That's the C++ and code. And these things represent simple components in the simulator. That's the basic building blocks that you describe using C++ programming language. Then you also have NED files and INI files. INI files is for controlling the simulation runs, setting parameters and things like that. The NED file is very interesting because that's where you build your network. So if you click on the NED file, and now I took example number 1 from the tutorial thing, I get a strange error. Oop. I don't know what that error means. Never mind. Okay. So, okay, but there is some strange thing here. I should get a graphical. Oh. So when you open a NED file, you should really get 2 tabs here, one graphical and one text. This is the text view. You should be able to get the graphical view as well. Oh, package NED. Here, design and source. Yeah, that was not so interesting. Why didn't I get it here? Now I got it. Design and source. So you can work with these NED models in a design tab. You can look at it more graphical here in view, or the source file. The graphical is kind of, well, the textual source is more convenient, I think. But here you define your network. So here we say that this network has 2 submodules, a tick and a tock. Each submodule is of this type, the TXC1 type, which is the simple component here. And this simple component has C++ code connected to it. So you first build your simple components and do C++ code, and then you can build a network using these components. So this tells you that you have 2 nodes, tick and tock, and they are connected with links here as well, with a certain delay time. So the out port of the tick is connected to the in port of the tock, and the other way around. And in the graphical view, we should be able to see this, I think. So it's, yeah, so they are, it's a network, two nodes, and they have a bidirectional link between them that can send data back and forth. And now I dragged around here, then it entered as this extra attributes display. It's because I changed the graphical view. It added some hints for the graphical stuff. It doesn't change the meaning of anything really. Maybe I can undo it. Oh yes, I could. Yeah, that's cleaner. But now it's ugly again. No, it's not ugly. Strange. Okay, so this is a very simple network. So when you run it, you typically run one of these NED files. You mark one NED and then press run. And then it's, yes, they have a configuration TikTok1, that's good. And then it actually builds the project and then starts the simulation. And now we have a very simple network. It's at time0 here. We have some scheduled events. In the future, we have one message at time 0.1. So there is one event waiting to be simulated when I press step here. And it's, so well, let's press step. We can see that now that event occurred, it was TOC that sent something to tick. And we can see here that at time 0.1, something happened here. One message was sent. And next, we actually have a TikTok message. Let's see, hard to read, but if we step here, we see that the tick creates a new message and sends back. And that's the way this goes. So if we run it, it will TikTok and send a message back and forth. And we see that the time increases all the time, but we can also do fast. Then it turns off the graphics and just simulates really fast. Oh, now I took express and then stop. Now it's simulated 500,000 seconds here. Oh no. And it created 200,000 events, messages. So that makes it difficult to actually understand what happened. We can reset the simulation here. We build network. No, we couldn't. Okay. But yes, so that's the way you can run the simulator. And there is a lot of features. So, but oh, wait, the main interesting thing for those that are interested in code is what's actually this model is doing in the C++ code. And a simple module has typically two functions only, one initialize and one handle message. And in the initialize, that's when the simulation starts. If you are tick, you create a message. If you're TOC, you do nothing. And then it actually handles the message by sending it out. So it will be, it will send out the message to the other module here using the out gate. And what's out? Well, we might need to look in the NED file so we can see that tick and TOC both has an out and in port. So that's the names of these input and output ports.
Förlåt Thomas, men fungerar den här out då i den här message där uppe i den här CC alltså med dubbelfnuttar, då vet den att det är den.
Ja.
Du har ju dubbelfnuttar på den där nere.
Yes.
Förlåt, svenska, men jag orkar inte. Men,
It's a strange mix between variables, types, and strings.
Okay.
And you need to look at some examples of how you should get everything working. But this out string here refers actually to this name in the in the NED file.
Okay.
So there is a lot of magic code happening because the NED file is not really C++, so it gets translated into code at some building stage.
Okay.
So you need to just, yeah. But the best way is to look at examples. And for those that dislike programming or C++, you don't really need to look in the code. You can just use this simple components. The existing simple components is free to use. And you just build your networks and set parameters and do simulations. You never touch the code. So you don't actually need to, but it's good to know that for all simple components, there are code in that you can find and read and try to understand. That's the thing. But yeah, there are a lot of features. When you run things, for example, you can inspect while you simulate. You can stop and then you can press a component here and inspect variables and watch points and things like that. Here is a record where you can do event log recording, and then you can get nice diagrams that shows all events that occurred. So that's part of the TikTok tutorial, to go through and become familiar to all kinds of stuff you can do. But I think I will not tell you any more about Omnet today. I think it's better to read and think tomorrow for yourself, and then you can ask questions because it's quite a lot to actually learn in a very short time. You need to sit down yourself and try to understand. But here is a little bit repeating here. So we have the NED files where you can construct network of simple nodes where you build your simulation model. And you have, for all simple components, you also have code, but sometimes you use already made components. You don't need to touch the code. If you're not, you can do your own components, then you need code. That's for sure. You also have an ini file. That's where you control different types of settings, like what network should we run? It refers to this network name here. How long should the simulation time be? And you can set different parameters. So in the ini file is where you set a lot of things, and then you start the simulation to check out the results. Yes. So yeah, TikTok. I have a player throwing a pair of dice. No, I don't think I will show that. It's too much. I will just describe a little bit actually about SimPy as well. And the lab class tomorrow, I got a question here from Anton. Yes, it's the lab class tomorrow is really supervision. If you need help and got questions. So you can actually do everything by yourself. That's perfectly fine. But you need to talk to me when you're done and want to get kind of examined in some way. So, but it's perfectly fine to work by yourself, and you can start already tonight. I will put up all stuff afterwards here now. So, but Omnet is a bit complex, so I can actually recommend joining tomorrow, really. That's for sure. Okay, so SymPy, a little bit about SymPy for those that likes Python. It's also similar to Omnet that you use components, but here it's processes that communicate. So a program can look like this. So you have, so you import the SymPy module, and then you need to create an environment, and then you actually create a lot of processes and start the simulation with a run here. And a process might look like this. This is a normal Python function, but it's a little bit special because it uses the yield. So it's actually a generator function. It's a little bit strange thing. So yield is almost like a return, but it can continue running. So it's like a forever running thread or something, or a co-routine. It's a correct name. So here, for example, you do 2 processes using this clock function, and you give it the name fast and slow and give it different tick times here. And the yield is actually a timeout event using this tick time to schedule an event in the future. So it's very similar to Omnet. You have events, you schedule them in the future. You have components that interact, and that's the processes here. So it's the same thinking. It's event-based and processes running logically at the same time, you can see, but in Python, it actually runs sequentially. So this is the way you can actually, so you build networks or many processes together, and you can then, yeah, build more complex simulator stuff. So let's see, yeah, for if you're not familiar to Python 3, well, ask me and I will help. For Windows, there is a simple idle environment that works perfectly fine. You have the command line in Windows or Linux, and I like the IPython3 command, which is a more convenient environment. Later for the project, it might be really nice actually to do nice diagrams, and Python and the matplotlib is really nice if you want to do some diagrams or stuff. You can do it in Excel or some spreadsheet, but sometimes it's more efficient to actually use Python. For example, these lines, I can start the IPython3 here. If I paste them in, I will get this diagram, for example. So here I create random numbers. No, this is a sinus curve. The B here, the A is this random stuff. And then I plot them and show them, and it will be in the same diagram. And you can have titles, you can control axis, you can do a lot of things. And sometimes Excel or spreadsheet is more efficient, but if you're doing repeated measurements and want to produce 10 similar diagrams, then you can really save a lot of time using Python, because you can actually generate all these 10 figures diagrams automatically, maybe from some data. So that's actually quite, can be very efficient. But that's for the report and for diagrams later on. So yes, so SymPy, how will it? Well, SymPy in 10 minutes. You should, if you do this, you should read about the different examples here. But otherwise, the car wash is the actual assignment. That's one of the examples existing here. So here you can see a slightly more complex thing. You have classes and you have many types of processes. You have a washing processes that washes cars, and you have a car that can be washed, and you have resources. So the car wash is a resource, really, and there are 2 car washes here, so you can have 2 cars at the same time washing, and there's a setup function that creates a car wash, and then a number of cars, and each car is a separately running process here. It's kind of separate component. So yes, this is the thing you should look at and extend if you do the Python thing and SimPy thing. So, and when you simulate, you actually only get text output like this. So that's, you need your own prints everywhere to actually see what happens. It's not, yeah. So it's not something very automatic. So the SimPy framework is really a way of structuring your simulation programs to make it, well, it's a way to hopefully make it more simple to do simulations. But that's, well, that can be discussed. It depends on the simulation. So I think yes, that's enough, I think, for this introduction. But yeah, so